So today we're going to talk about factor trees and why they're useful if you're asked to solve for a greatest common factor, or GCF. So first of all, we want to talk about what is a prime number. So I like to think about a prime number as a number that you can't reduce down into simpler whole numbers that you multiply together. For example, if you take a number like 6, you can reduce that down to 2 times 3. 6 is the same thing as 2 times 3. So therefore, 6 is not a prime number. If we take a number like 5, the only whole numbers that we could multiply together to get to 5 are 1 times 5. So in other words, the only factors of 5 are 1 and itself. So a prime number then, as a definition, would be a number which only has factors of 1 and itself. Or another way to say that is, you could say a number which is only divisible by 1 and itself. So if you think about the set of prime numbers, 2 is actually a prime number, which is always kind of surprising to me because it's even, but the only numbers that you can multiply together to get 2 are 1 times 2. And so therefore it's prime. 3 is a prime number. 4 is not, because 2 is a factor of 4. 5 is, 7, 11, 13, and so on. So if you know those first few numbers, that will really help you with the factor trees. So let's take a look at a question like this. Here we're asked to figure out the prime factors of 18. So we're going to write 18 at the top, and then we're going to ask ourselves, what numbers can we multiply together to get to 18? So we could do 2 times 9. So I'm going to put those down as branches. And then 2 is already prime, so we've done that part of our tree already. 9 is not prime though. We can break that down further. So we know 9 is 3 times 3. Since 3 is prime, we're now done. And we could write this in another form. We could say 18 is 2 times 3 times 3, or you could even write that in exponential notation like this. 18 is 2 times 3 squared. Now you might be saying, well, that's fine, but I was actually thinking 18 is 3 times 6, because there's more than one way to do this. So let's do 3 times 6. 3 is already prime. 6 we can break down to 2 times 3. 2 and 3 are both prime. So we end up with the same thing. 3 times 2 times 3. Or you could write this as 2 times 3 times 3 if you want. It means the same thing. So no matter which path you choose to get there, you'll always end up with the same answer. Let's try one more. So here we're asked to find all of the prime factors of 70. So we're going to write our number at the top, 70, and we think of 2 numbers we can multiply together to get to 70. So I'm going to do 7 times 10. And that 10 we can break down further into 2 times 5. So we end up with 70 is 7 times 2 times 5. Now you might be saying, well, that's all well and good. I can find the prime factors of a number, but why would I want to? Well, doing the prime factors and doing a tree like this can really help you with greatest common factor. It can also help you with least common multiple, but today we're going to talk about greatest common factor. So let's say you were asked to find the greatest common factor of 2 or more numbers. So here you want to think about all of the factors, and then you've got to find the one in common between those 2 numbers, which happens to be the highest factor that is in common. So what we're going to do is we're going to write down both of those numbers. So we've got 27 and 36 over here. And once again, we're going to do our factor trees. So 27 is 3 times 9. And that 9 I can break down into 3 times 3. And now I'm left with just 3's, so which is prime. So we're done. 36 is 9 times 4. 9 we can break down to 3 times 3, and 4 is 2 times 2. And now we're left with just 3's and 2's, which are prime numbers, so we're done. Now to figure out the common factor, what you want to do is circle anything that is common to both trees. So we're looking only at the branch tips here. So you're only looking at your prime factors. So I'll just underline those. So we're only looking at these numbers here, and we're asking ourselves, which ones are in common? Where do we have a pair? So I have a pair of 3's here. And then we have a 3 here and a 3 here as well. So we have another pair. Then we have a lonely 3 over here. So we can't circle that one because we don't have a 3 on the other tree. And we can't circle these 2's because they don't have a pair on the 27 tree. So now if we think about what we have in common, we're going to say the greatest common factor then is just multiplying those circled numbers. So look at only one of the trees, doesn't matter which one you look at. I'm going to look at this one. And the circled numbers are 3 times 3. So in other words, our greatest common factor here would be 9. And if you look back at the original question and think about the greatest common factors of 27 and 36, you could actually list out all of the factors if you wanted here. So 27, we would have 1, 3, and then we've got all the way till 9, and 27. And then if you look at the factors of 36, we've got 1, and then we have 2, 3, 6, 9, 18, and 36. And so you can see that the greatest one in common between those two is 9. This method here with the factor trees just helps you to do that in, I think, an easier way. So happy factoring, and let me know if you have any questions.